In this topic, we turn business, compliance, and security needs into a concrete EUDI Wallet onboarding architecture. You'll see how KYC, risk, credential issuance, and integrations fit together, so we can later dive into detailed flows, trust relationships, and edge cases. You've already built a strong foundation. You explored the EIDAS 2.0 ecosystem and the wallet journey. You shaped a concrete onboarding and KYC use case with clear requirements. You aligned it with GDPR and AML controls. Now we'll use that groundwork to design a concrete component architecture. A target component architecture is the bridge between requirements and implementation. It breaks the system into clear building blocks, each with a specific responsibility. User interactions live in one layer. Orchestration and verification sit in another. Evidence and audit have their own space. This separation gives you clean ownership for security, privacy, and compliance. It also becomes the reference model for selecting vendors, designing integrations, and producing detailed sequence and deployment views. Think of wallet-based KYC as a relay race. The onboarding channel talks to the customer, collects their consent, and captures the wallet response. The relying party backend coordinates everything. It sends the presentation request, receives wallet data, and calls downstream services. The verifier confirms credentials and trust chains. Then KYC and audit services apply rules, record decisions, and produce evidence. Clear separation of these roles prevents brittle integrations and makes compliance and troubleshooting far easier. The onboarding channel is the customer's first touchpoint, so it must feel smooth, consistent, and trustworthy across web, mobile, and partner journeys. Its job is to guide people from "I want an account" to "My identity is verified" using wallet-based credentials. It presents verification options, triggers deep links or QR scans into the wallet, captures consent, and displays status and errors, while minimizing how much sensitive identity data it actually stores. Here, the channel becomes the customer's anchor. It keeps the application session alive while the wallet does its work somewhere else. The wallet holds verified identity. The channel never becomes the system of record. Instead, it explains what data is requested, why it's needed, and under what legal basis, and it shows clear consent choices. It then surfaces status updates, and if verification stalls or fails, it gently routes users to a fallback or manual review path. Now think of the relying party backend as the conductor of the onboarding orchestra. It creates a session for each customer, tracks a correlation ID, and drives every step from the first click to account creation. It triggers wallet presentation requests, sends attributes to KYC, AML, and fraud checks, and collects their decisions. It then updates customer profiles, notifies operational systems, and consistently enforces policies, API security, rate limits, and integration rules. Treat the backend as a product with clear capabilities, not a giant script. It first exposes simple onboarding APIs: start, check status, resume, cancel, and complete. It also tracks workflow state while storing only the minimum identity data needed. It reacts to events such as verification outcomes, KYC decisions, and manual review results. And every call is protected and observable, with strong authentication, throttling, validation, and integration hooks into regulated systems. The verifier service is the gatekeeper between a user's wallet and your backend. It takes a KYC request, formulates a presentation request, then receives the wallet's response over an agreed protocol. Inside, it runs a validation pipeline, checking signatures, credential integrity, issuer trust via registries or metadata, current status, expiry, and audience binding. Only after all checks pass does it output normalized results and verified attributes your backend can safely consume. The verifier is a technical trust service, not your entire onboarding brain. Its job is to validate protocols, check cryptographic proofs, and confirm that the credential presentation hasn't been tampered with. It then normalizes the claims so downstream systems see clean, consistent attributes. Business meaning stays outside. KYC rules, risk scoring, and final approval decisions belong to the relying party. Likewise, long-term customer profiles and sensitive data storage should sit in dedicated systems, not in the verifier. Here, the verified attributes are just the starting ingredients. The orchestration engine combines them with AML and sanction screening, fraud and risk checks, and your custom business rules. All of that feeds into a risk score and an eligibility assessment. If the score is clean and complete, you auto-approve. If risk is too high, you reject. Borderline or unclear cases trigger either a request for more information or a manual review queue. Think of KYC decisioning as a pipeline with 3 layers. First, deterministic rules validate data, enforce policy, and tag records with a specific policy version. That gives you reproducible decisions. Next, risk scoring classifies customers into low, medium, or high risk using configurable thresholds. Finally, a routing layer decides auto-approve, auto-reject, or send a structured case to humans, complete with evidence, reason codes, and a full audit trail. Audit and evidence services act as the platform's compliance memory. They collect what decisions were made, why they were made, and which policy version applied at the time. Every verification, consent, and KYC outcome is tied to trace IDs and timestamps across channels and backends. You maintain strong proof that actions occurred, while avoiding over-retention of raw credentials. With tamper-evident logs, access controls, and clear retention rules, audits, investigations, and regulatory reporting become defensible and repeatable. Now step back and view this architecture as secure, private, observable, and governed by default. Every API call assumes zero trust. It's mutually authenticated, encrypted, and limited to least privilege. Every data element follows privacy rules. Only what's needed for a clear purpose, kept only as long as required. Every workflow is observable, traced, logged, metered, and alerted. And every component has an owner who is accountable for operations, incidents, audits, and change control. You've now seen how a wallet-based KYC platform is broken into clear responsibilities. The channel collects data, the backend coordinates, the verifier proves technical trust, the KYC engine applies policy and risk rules, and audit services preserve evidence without hoarding PII. Next, we'll bring this architecture to life with concrete flows. The full onboarding journey, trust validation, and credential lifecycle, and how failures and manual reviews are handled end-to-end.